project is going to be about implementing a smart power meter network. Firstly, each box here represents the customer premises, which includes the meter, load, and the smart device, which can be a PC, as in this house. The next network is the ISP network, which includes the central office server, which is used to manage the cell towers, which were used to serve the meters mainly. These are the infrastructure for the power meters, and also includes the DNS server, along with the core router. The third network, which is the main network, is the electricity company network. We call it SEC as refer to Saudi Electricity Company. This network includes a field maintenance engineer laptop, which will be used to receive emails as a complaint for a connectivity issue for any meter. And the main part is the SEC server, which does most of the work for the network, for the analysis and checking connectivity. Other networks are used just for having emails for the customers, Gmail and Hotmail. We can see here the power meter takes the readings from the load. Each load has a different characteristic. We defined it using the environment. And as we can see, each meter is showing different readings based on the connected load. Now, let me discuss the function of the server. The server mainly has two functions. It checks the reachability for each meter. We have implemented 4 power meters in our network. The server keeps pinging or probing the meters. We assigned each minute to send a TCP packet and check the reachability for each meter. If the meter is reachable, it will log it as reachable. As we can see here in the connectivity check, the server has a counter in order to identify the meter. If the meter has replied, then it will reset the counter. If there is no reply from the meter, let's say meter X does not reply to the server, this means that there is a reachability issue to this meter. It will increment a counter. If the increment reaches 5, the server will send an email to the field maintenance team informing them that meter X is down, take actions in order to restore it. If still the meter is still down after 8 tries, it will send a reminder email to the field maintenance in order to take urgent actions to restore the meter. I will make a demo for the connectivity check. We can see here now meter 1 is not reachable as logged by the server, so we'll fast forward in order to check. Now, checking the field maintenance team email, we should receive an email. This is the first email. Dear team, please support to clear the issue in meter 1. And because the counter incremented till 8, the server sent an email. Dear team, please update. Meter 1 is still down. So these are the 2 emails that are sent in order to restore meter 1 to the field maintenance in order to take actions. Now let's assume that action have been taken. So now meter 1 is reachable again. Now the second main part of the server, it's basically the database. Basically, after each cycle, the server will take the meter reading. The server will keep listening. It's basically a TCP server, and we have established TCP clients at each meter. Whenever the cycle is completed, for our scenario, we have made the cycle 10 minutes. After each 10 minutes, we assume that this is the end of the month. So if any meter sends the data, the server identifies first the meter, which meter has sent this data, by the IP address, of course, because we have set it, gave it a static IP, so we can identify which meter sent the data, and then store the reading of the meter, then calculate the consumption of the current one, which is taking the delta of the current reading minus the previous meter reading. After calculating the consumption, we generate the receipt, how much the amount is due for this month. We assume that if the customer consumed 6,000 watt hour less than this amount, his amount will be calculated as the following: consumption multiplied by 0.18 halalas. if the consumption is more than 6,000 watt hour, for the first 6,000, it will be 18 halalas, and the excess amount is going to be 30 halalas. At the end, send an email with the bill to the user. Since this was running for almost 2 hours, we will have 60 and 40. We will have 10 emails sent now to the customers. So if we check randomly this user, if this user checks his email, we can see that this customer has received an email for every month that has elapsed. And we can see inside the email, dear customer, we hope that our services were satisfactory. Please note that your electricity receipt has been issued with below details. Now, this is the receipt number. This is the month meter reading. This is the current reading of the meter. And this is the last month's reading. And this is the consumption amount, which is basically the delta. And this is the amount due based on our calculation criteria that we have just shown. And also it will show the previous amount due, how much he had an amount due for the previous month. That's too much. We have shown the details for how we calculated the consumption for the customer. The last thing is that we have added the feature of enabling the user to see his consumption in real time. So if we, let's say, user 1 wants to check his consumption, he gets to, basically this is the IoT registration server. So when this customer, for example, logs in, he sees his meter connected. He has access to the real time of his meter reading, his amount due for this month, and his consumption for this month. Plus there is one message that is showing that, okay, your consumption currently is within slot 1. If his consumption for this month reaches 6,000, let's say between 5,000 and 6,000, it will show him a warning that your consumption is getting higher. And this will result in increasing your bill, of course.
In conclusion, despite the simplicity of the implemented network and algorithms, the concept of acquiring real-time electrical meter data is found to be both feasible and beneficial to the company and the customers. All data sent and received use TCP, which ensures the integrity of transmission. However, encryption is strongly recommended in real-life applications. Finally, I hope this video was informative, and thank you for watching.